All right, next up, we've got stoichiometry, right? And so there's two parts to this, using the units in 1D through Fs. That's like molarity, percent mass, that kind of thing. And then there's the limiting reactant and percent yield. We're going to try using these units first and just doing some basic stoichiometry, and then we'll go on to that one. But it's all about unit conversion. Unit conversion, unit conversion, unit conversion. And in order to pass this class, you really got to be able to convert units. So let's go ahead and take a look at this question. It's quite a difficult question. Uses a lot of different conversion units. So let's go ahead and figure it out. So the question asks is how many grams of an 11% by weight solution of sodium hydroxide would you need to fully react with 100 ml of 0.5 molar H2SO4? And it gives you the concentration or the molar masses of these compounds, and it also gives you this equation. So 2 sodium hydroxides react with 1 sulfuric acid to give 2 waters plus 1 sodium sulfate. So as you can see, the equation is indeed already balanced, so we don't have to worry about anything there. We just got to start converting. So for this kind of stuff, you kind of want to identify what you want, and what we want at the end is how many grams of this solution, right? How many grams of this 11% by weight solution. So at the end, we want grams of sodium hydroxide solution, right? Some number of grams of sodium hydroxide solution. And then we can take a look at what we have. So the first thing we have is that it's 11% by weight solution of sodium hydroxide. So if you remember from the last video, we can rewrite this as a conversion unit. We can write it as 0.11 grams sodium hydroxide over 1 gram of sodium hydroxide solution. Here I'm indicating what type of solution because we have two different types of solutions. We have the sodium hydroxide solution, and we also have the sulfuric acid solution. So one's going to be sodium hydroxide, the other one's going to be the solution, right? So there's one of my conversion units. Let's take a look at another one. So you would need to fully react with 100 mLs of this 0.5 molar H2SO4. So that's another piece of data that we're given. So we know that we have 100.0 ml of this sulfuric acid solution. So H2SO4 solution. There's another piece of data that we're given. Let's see what else we're given. So we have the 0.5 molar H2SO4. And if you think about back to molar is moles solute over liters solution. So we have 0.500 moles of H2SO4, right? That's our solute over 1 liter of H2SO4 solution, right? It's moles solute over liters solution. Cool. Next pieces of data that we're given is this 39.997 grams per mole of sodium hydroxide. So we can say that we have 39.997 grams of sodium hydroxide over 1 mole of sodium hydroxide. And again, I'm being really explicit, writing all of the units in a measurement, right? The number, the unit, and then the subject that we're talking about. And then it also gives us the molar mass of sodium or of sulfuric acid, which is this 98.079. So we know we have 98.079 grams of H2SO4 over 1 mole of H2SO4. So you should be very comfortable with going from moles to grams using molar masses, right? These are numbers that you'd pull off the periodic table, but a lot of times in the interest of time for a test, these units will be given to you, and then you'll have a separate question making sure you know how to do this stuff. Cool. So what else do we have in this problem? Well, we think about, we're given this equation. So what stuff can we pull about from this equation? Well, what we really care about is the sodium hydroxide and the H2SO4. We don't really care about anything else. The question isn't really asking about anything else, so we can use that as a piece of data. And so this is a mole to mole conversion. So we know we need 2 moles of sodium hydroxide for every 1 mole of H2SO4. So we can write something like 2 mole NaOH over 1 mole H2SO4. All right, back to this question. It looks like we've pretty much used up all of our pieces of data. Right, we got this as the want. We identified the 11% right here. The 100 grams came from here. The H2SO4 concentration came from here. And then we got these molar masses as well, right? We got these molar masses as well that we used here. And then finally, we got our mole to mole conversion from this problem right up here. So lots and lots of data to use. This problem can be pretty intimidating, but if you write out what you want, what you have, you can kind of just start piecing them together. So again, at the end, what we want is the number of grams of sodium hydroxide solution. And as you can see, we've got a lot of different choices of where we're going to start off with. In general, I suggest starting off with the thing that's not a conversion unit, the thing that is not a conversion unit. And so the only thing here that doesn't compare two things is this 100 ml of this sulfuric acid solution. So let's go ahead and take that number and start off with that. So we have 100.0 ml of H2SO4 solution, right? And you can see we've got a lot of different things that we can be talking about here, so it's important to kind of keep track of what you're talking about. All right, so now that you know your starting point, now you're just going to link them together until you get to where you want, grams of sodium hydroxide solution. So we see that we have this sulfuric acid solution, so we want to take a look at where else do we have sulfuric acid solution. And where else we have it would be right here, right? That's the only other place that has the sulfuric acid solution. But we notice the units here are in liters. Down here, we are in milliliters. So before we can even use that conversion unit, we gotta go to liters. So this is a conversion unit you should be able to do easily. It's 1000 ml to 1 L. And so what's gonna happen here is the ml is gonna cancel out with the ml. So you'll be left with liters, and now we can go ahead and use this conversion unit, right? So we're going to plug this in right here. We have liters of H2SO4 on the top, so we can leave it just as it is, and liters of H2SO4 should go down on the bottom. So 1L H2SO4 solution, 0.500 moles of H2SO4. And so we can see a number of things are going to cross out here: H2SO4 solution, H2SO4 solution, as well as these liters, So now we're at moles of H2SO4. Is that what we want? No, we want grams of sodium hydroxide. So we got to keep going. We take a look at, we have 0.5 moles of H2SO4. So we identify that right here, and then we have to think about where else do we have moles of H2SO4. And when we look at it, you actually have it in multiple different places. You actually have it right here, and you have it right here. So this unit up here up top will let us go to grams of H2SO4, while this number down here on the bottom will let us go to moles of sodium hydroxide. And so you've kind of got to make a choice here. And so the only really way to kind of do this is to kind of think ahead a little bit. And at the end, what we want is we want grams of sodium hydroxide. So eventually we're going to have to get to grams of sodium hydroxide. And so this one includes, this bottom number includes sodium hydroxide. This one up here does not. So that's a hint that you're going to want to go with this one, right? Going to grams of H2SO4 is not going to help you. So let's go ahead and use this unit right here. It's already organized the way we want it. We have moles of H2SO4 on the top, so we can put moles of H2SO4 on the bottom. So we have 1 mole H2SO4 over 2 moles of sodium hydroxide. When we go ahead and do that, moles of H2SO4 and moles of H2SO4 are going to go ahead and cancel out. So I'm going to go ahead and continue this conversion unit. I'm just going to continue it over here. That way when I print it as a PDF, it looks nice and the spacing doesn't get all wacky. So now we're at 2 moles of sodium hydroxide. Do we want moles of sodium hydroxide? And the answer is no. We want grams of sodium hydroxide solution. So we're getting closer. Going from grams to moles, you should know how to do this at any point. But if you don't, here we've got moles of sodium hydroxide. We can take a look at where we can use that. We have it up here, but we already used this unit, so that's just going to take us backwards. There's no point in using that. If we look up no sodium hydroxide here, right? Oh, look, we've got a mole of sodium hydroxide right here. And if you look at the rest of the unit, there is no more moles of sodium hydroxide. There's grams of sodium hydroxide, but that's not the same thing. So that should give you an indication that this is going to be the unit that you want to use. So let's go ahead and plug that into here. Follow this arrow all the way down here. And so moles is on the bottom here. It's on the top here. So they're just the way we want it. So the conversion unit here is going to be 1 mole of NaOH. And on top is going to be 39.997 grams of NaOH. And so here, what we'll see is that our moles of sodium hydroxide are going to cancel out. Moles of sodium hydroxide are going to cancel out. And then we'll be left with grams of sodium hydroxide. So if we read the question, are we at where we want? Well, we actually know, right? It grams of sodium hydroxide, yeah, but it's grams of sodium hydroxide solution. So we're actually not where we want to be yet. So let's figure out the next step. We have here grams of sodium hydroxide. Let's take a look at what we have and see where grams of sodium hydroxide shows up. So not there, not there. We have grams of sodium hydroxide right here, but we just used that unit, so that's not going to be useful. That's just going to take us backwards. Not there, not there. Oh, well, look what you know, right there. Grams of sodium hydroxide, and it'll lead to grams of sodium hydroxide solution, which is exactly what we want. So we want to go ahead and use this conversion unit next. So I'll pull this number all the way down here. And then the next thing you need to notice is that grams of sodium hydroxide here is on the top. So in order for it to cancel out, grams of sodium hydroxide has to be down here on the bottom. And if you take a look at the original unit, it was actually on the top. So you have to flip this unit. That's totally fine. All of these numbers are just 1, so they're all just 1 over 1. You can flip it and it still means the same thing. So we'll plug that in. 0.11 grams sodium hydroxide over 1 gram of sodium hydroxide solution, right? So you can see with this problem, it's especially important to keep track of what unit means what. And so grams sodium hydroxide, grams of sodium hydroxide cancel out. And now we're grams of sodium hydroxide solution, which if we look at our want, that is exactly what we want. So we're right where we want to be. And so we can just go ahead and plug and chug through this, right? So that at the end, we'll get grams of sodium hydroxide solution. And now we just need to take our handy dandy calculator and plug through. So we'll do 100 divided by 1000 times 0.5 times 2 times 39.997 divided by 0.11. And let's see, we only have 3 sig figs here. So our final answer will have 3 sig figs, I believe. Yeah, it's 11.0, so this is 0.0. So this should be 36.4 grams of sodium hydroxide solution, and that's your final answer for this problem. All right, so next up, we've got limiting reagents and percent yield. So this is, again, our sandwich analogy. If you had 1 slice of cheese and a billion slices of sandwiches or a billion slices of bread, 1 slice of cheese, you can still only make 1 sandwich. So let's take a look at this in terms of chemistry. So we'll go down to this example problem. You produce 12.5 grams of Freon, gives you the molar mass, from 32.9 grams of CCl4, gives you the molar mass, and 885 grams of HF. And then it also gives you the equation that CCl4 plus HF produce CF2Cl2 plus 2 HCl, and then there's a 2 here. So it gives you quite a bit of data. How are you going to solve this? First, you should take a look at the question is, and in this case, the question is, what is the percent yield? Forgot to put that. The percent yield. So it wants to know, what is the percent yield? Well, so if we think about what percent yield is, this is something that you have to know. It's your actual yield over your theoretical yield times 100% since it's a percentage. So back to the sandwich analogy, if you had enough supplies to make 100 sandwiches, but you got hungry along the way and you only ended up making 10, then your percent yield would be 10. So let's take a look at what numbers are given and how we can plug those in. So the first thing is it says you produce 12.5 grams of Freon. That's how much you actually made. How much you actually made, that's the actual yield. And so we can go ahead and plug that number right into there. The second part, in order to get percent yield, we're going to have to know is theoretical yield. And so for that, we're going to solve how many sandwiches could you have made? In this case, how much Freon could you have made? And these problems go in the general order of starting off of grams of one thing, grams of A, going to moles of A, then moles of B, and then back to 2 grams of B. So at the end, that's what we're going to want to figure out. This grams of B is going to be our grams of Freon, and then the grams of A is either going to be the CCl4 or the HF, the bread and the cheese, right? So to figure out how many sandwiches you can make, you have to think about how many sandwiches you could make with the amount of bread and the amount of cheese, and then combine those two. Whichever one gives you the lowest number, that's the one that wins, right? So again, 1 slice of cheese, 1 billion slices of bread, you can only make 1 sandwich. So you can pick either thing to start off with. So let's go ahead, just going to arbitrarily pick this grams of CCl4, grams of CCl4. So that's what we're going to start off with, 32.9 grams of CCl4. So that's our grams of A. So next thing we got to go is to moles of A. How do we go from grams to moles? Well, we use the molar mass, which in this case was given to us, right? 153.82 grams per mole. So we write that 153.82 grams per mole, grams per mole, right? And so you just have to be careful. Make sure the molar mass you're using is indeed talking about what you're talking about. So this is indeed the molar mass of CCl4. So grams cancels out with grams. So we're good there. Now we've got moles of CCl4. Well, no, we need to get to grams of the Freon. So how do we do that next step? Well, we got to keep going on, right? So that was grams of A. Now we're at moles of A. Next step we have to do is go to moles of B. When you're going from moles of one thing to moles of another thing, what do you need to use? Yeah, it's your mole to mole conversion. In this case, we're going CCl4, so there's one of them. And at the end, we're going to Freon, the CF2Cl2. So it's a 1-to-1 ratio. So this isn't going to change the number, but it's still good to write. So from every 1 CCl4, you can make 1 CF2Cl2. And so CCl4 is going to cancel out. Now we're at moles of CF2Cl2. So we're at moles of B right now. And then finally, we have to get to grams of B. How do we go from moles to grams? Of course, it's the molar mass. Hopefully you know that at this point in the course, right? So here's CF2Cl2, and it's 120.91 grams per mole. Since moles is up here, moles has to go down here. And so the 120.91 grams goes here. And then at this point, you can see moles cancels out with moles. And so then you're left with, grams of CF2Cl2. And then you just got to plug and chug through there. And what you'll end up with is this 25.9 grams of CF2Cl2. What you heard was my speaker falling. All right, so, but we're not done yet, right? This is just the cheese or the bread part, right? This is just how many sandwiches we can make out of that component. We have to think about the other component. In other words, we have to find out what our limiting reactant is, what our limiting reagent is. So if you have 1 billion slices of bread and 1 slice of cheese, that 1 slice of cheese is your limiting reactant. So you essentially have to do this process twice. So it's not too bad. I'm going to go through this part pretty quickly, right? So in the next set of the problem, what we're given is that we also have 885 grams of HF, right? So one of them is your bread, one of them is your cheese. You got to compare them. So we can start off with our 885 grams of HF. Well, how do we go? We're going to follow the same procedure: grams A, moles B, grams B. So how do we go from grams of HF to moles of HF? You use the molar mass, right? So this is 20.006. 20.006 grams per mole. Grams going to go ahead, cancel out. How do we go from moles of A to moles of B? We use our mole to mole conversions, right? Our mole to mole conversion ratios. So in this case, we have 2 HFs and only 1 CF2Cl2. So down here we put 2 HF, up here we put 1 CF2Cl2. And you can see the HF and the HF cancel out. So now we're at moles of CF2Cl2. Now we have to go back to grams of CF2Cl2. How do we go from grams to moles? Again, it's the molar mass, so we're going to use this again. So down here we have moles. Up here we'll put 120.91 grams. Grams or moles and moles are going to cancel out. We'll be left with grams of CF2Cl2. So I did this quite quickly. If you want to refer back to the previous problem we did and kind of think about what you want and what you have, I definitely recommend it. But in this case, I'm going to fly through this quickly because you should be pretty comfortable with gram to mole conversions and mole to mole conversions, which is all this problem requires. Anyway, so you plug through the math, you get 2,670 grams. So you've got two numbers here for CF2Cl2, right? So that's your limiting, or that's your theoretical yield. So which one is the real yield? And again, it goes back to the sandwich analogy. If you had 1 billion slices of bread and only 1 slice of cheese, you can only make 1 sandwich, so the cheese is the limiting reagent. In this case, one of them can produce 25.9 grams of Freon, the other one produces over 2,000 grams of Freon. Well, it doesn't matter how much HF you have because CCl4 is going to be the limiting reagent, right? We can only make this amount. So this right here is the limiting reagent. So that's important to know. So that's what goes into our theoretical yield, right? This is the number that we plug into our theoretical yield. And so again, back to finding percent yield, actual over theoretical. From the problem, we saw that the actual was this 12.5 grams. And the theoretical was this 25.9 grams of CF2Cl2 times 100 to make it a percent. And you end up with 48.3% yield. So that's like maybe you could have made 100 sandwiches, but at the end you messed up so many times you only made 48. So this 48 is our final number, and you should be very comfortable with these types of problems. There's guaranteed to be these types of problems on the test. Again, it's stoichiometry. It's just unit conversion, unit conversion, unit conversion. The only way to be comfortable with this stuff is practice, practice, practice. So you should practice, practice, practice.